Hi everyone, welcome all. Hope all of you fine. And we are going to give a brief explanation about some of the optical phenomena and its application. Before start class, let me to share the screen for the detailed explanation. In our day-to-day life, we are familiar about so many spectacular phenomena like the formation of rainbow, shadow formation, twinkling of stars, etc. What would be the reason behind this? This is because of some of the optical phenomena like that reflection, refraction, diffraction, etc., dispersion, etc. Likewise, have you ever seen that the bottom of a water pond appears to be some heights and also a partly immersed pencil displaced at the interface. Seems to be displaced at the interface of air and water. What is the reason behind this one? This is because of the optical phenomena refraction. Before coming to refraction, in smaller classes, we all might have learned that the light is traveling in a straight line. But apart from this one, when light is entered from a optically rarer medium to optically denser medium, it will be deviate its path at the interface. This is known as the refraction. And as the light is entered from a rarer medium to denser medium, the refracted ray will be deviated towards the normal. Similarly, when it is entered from a denser medium to rarer medium, the refracted ray will be deviates away from the normal. And here today I'm going to explain the image formation by the convex lens and what are its application. And this also we have learned that in smaller classes, image is mainly formed by the optical phenomena reflection. But it is not only because of the reflection, actually lenses are forming the images because of the optical phenomena refraction. Here the figures are showing the various type of the image formed by the convex lens at various distance of the object from the lenses. Each one we will be discussed briefly here. First one, what is a lens? A lens means that it is a transparent medium which is bounded by a two bulged outward surface which is known as a convex lens. A lens can be a convex lens, a concave lens, or one face will be a plain face and another one will be a curved face. Here we are going to discuss about a convex lens, image formed by a convex lens. Here the figure is showing a convex lens on which a parallel beam of light is incident here. After refraction, here we can see that the refracted rays are converging to a single point, and this point is known as focus. This is why convex lens is known as a converging lens also. And this property of convex lens we are using for the treatment of the hypermetropia. We know for a hypermetropia person, the image is formed behind the retina. But when we treating this film with a convex lens, the image will be formed at the point of retina. The next one, when the image is placed beyond 2f, then we can see that here in this figure, two rays are coming from the object. After refraction, these rays are intersecting at a point. The parallel ray will be, after refraction, it will be passes through the focus, and the oblique ray through the optical center. Without suffering deviation, it will be passing through the convex lens. This will be intersect at a point, and the image will be a clear image will be formed between the f2 and 2f2. This property we can be used to see the images of some far objects, that is we are using the telescope. The next one, when the object is placed at 2f1, here also after refraction, the ray which is passing through the optical center and a parallel beam, that will be intersect at a point which is at 2f2, and it is in the first case, that is the when the image is beyond 2f1 and when the image is at 2f1, both are forming the real images here, and we can see that these are the inverted images also. This is also we are using in the telescope there. And next one, when the object is placed between 2f1 and f1, and here we can see that after refraction, the image is formed beyond 2f2, and it is an enlarged image, but it is also a real image, that is a inverted image is forming here. And the next one, when the image is, when the object is placed between the two F1 and the optical center, here we can see the after refraction, the rays are passing to some points here, but it is forming a almost after refraction, the rays are passing as a parallel rays here. This is why it is forming a highly enlarged images here, and it is also a real image. And the last case, when the object is placed between F1 and optical center, here we can see that after refraction, the image is formed on the same side of the object. Since it is formed on the same side of the object, this will be a virtual image. It will be an erect and enlarged image. And this property of convex lens we are using in the microscope. Microscope enables us to see get the magnified image of the object here. This is all about the image formation by the convex lens. So I concluding this class with the topic, the image formation by the convex lens. I hope it will be very understood for you. Thank you.